Okay, year 12, just like you learned how to differentiate when you've got a function inside a function, you learned the chain rule. Okay, so very similarly, we are now going to be integrating functions like these, which is a function inside another function, and we are going to be using reverse chain rule because we are doing the reverse of differentiation, which is integration. Okay, so the first example then is, and this is on page 296, okay, it's example 3, but I'm going to call it example 1. And our function is cos, so we're asked to integrate cos 2x plus 3 dx, okay. Now I always integrate these type of functions using substitution, okay, or you can call it reverse chain rule. So what I start with going back to our basics, we know how to integrate cos 2x or cos 3x or cos x, okay? But what we don't know is how to integrate something like this, cos 2x plus 3. So I'm going to start with making a substitution. I'm going to call this 2x plus 3 u. So let u equals 2x plus 3, and I will now differentiate it. So du by dx is 2. I will then work out what dx is, okay, because I need to find a substitution for this as well. Because if I substitute 2x plus 3 with u, and if I've got a dx there, which is telling me to integrate this function with respect to u and with respect to x, and if there's no x here, then I can't integrate this, okay? So I've got to work out dx in terms of u. So dx is equal to du over 2. And I'm going to put that there. So I'm going to have cos u du over 2. And I'm then going to take out the half, and I'm going to have cos u du left in there. And I know how to integrate cos u. If I go back to my list on page 294, I know that cos x integrates to sin x. So this will give me half sin u plus c. And now I will make my final substitution back, because my answer needs to be in terms of x and not u. So this will be the final answer for that question, okay? And this method can work for any function where you've got a function within a function, okay? So you can use this rule now if you see any, if anywhere you see a function within a function, okay? Part B, so you've got e4x plus 1 dx. I'm going to make a substitution, okay? I'm going to call this power u. So I'm going to say let u equals 4x plus 1, du by dx equals 4, dx equals du over 4, okay? Put my substitutions back. There you go. And now I can pull the 4 out, because that's just a constant, and I've got eu. Now all I've got is to integrate e to the power u with respect to u, and I know what that is. So that's going to give me quarter eu plus c, and I'm going to put the u back, which was 4x plus 1 plus c. Okay? Part C, I've got sec squared 3x dx. Going back to my list, I know how to integrate sec squared x. That gives me tan x. So let u equals 3x. Okay? Let u equals 3x. So that means du by dx is going to be equal to 3. And dx equals du over 3. Put all of my substitutions back. Pull the third out. Integrate sec squared u. That gives me tan u plus c. And put the u back, or put 3x back into u, plus c, and there we have it. Okay. Couple more examples before you can start 11b. Alright, so next example, which is on page 297. Okay, and again I've got find the following integrals, and first one is 1 over 3x plus 2 dx. Now which one is this related to? If I look back on my list, I've got a function of x in the denominator. Okay, so I'm gonna have something with ln. Now let's just use my method. Okay, it really requires you to think very little. So what you're going to do is just let 3x plus 2 be u. So let u equals 3x plus 2. Differentiate that. Du by dx is 3. Find what dx is. That is du over 3. Put that back. Now you know how to integrate 1 over u. That's just going to give you ln u plus c. And I've got the third out. Okay, so I'm going to pull the third out, and that's going to come here. And that is 1/3 ln 3x plus 2 in the modulus plus c. Okay. Part B. And I've got 2x plus 3 to the power 4. Okay, again, I've got a function inside a function. Okay, so I'm going to let u be 2x plus 3. Du by dx is going to be 2. Dx is du over 2. Sub that in. U to the power 4. Du over 2. Pull the half out. So you've got u4 du. You know how to integrate this from book 1. So that's going to give you half u5, increase the power by 1, divide by the new power, plus c. Okay, and this will now give you u to the power 5 over 10. Keep putting your equal signs there. Plus c, and then put your u back, which is 2x plus 3, so 2x plus 3 all to the power of 5 over 10 plus c. Okay, no need to expand out anything, you can just leave it like that. Okay, don't forget your c.